In this video, we're going to prove by mathematical induction that the sum from r to 1 to n of minus 1 to the r minus 1 of r is 1 plus minus 1 to the n plus 1 minus 2 times minus 1 to the n times n over 4. Okay, this is a much more challenging example, but the proposition is that from r to 1 to n of minus 1 to the r minus 1 times r, you need to write out a few terms of the series in order to realise what's happening. If you put r as 1 in here, you're going to get 1 minus 1, which is 0. So minus 1 to 0 is 1. So you're just going to get 1 as the first term. We put r is equal to 2 in here. This becomes minus 1 to the 1, which means it's minus 1 times 2, so it becomes minus 2. So this has an effect of changing the sign. So the series will go 1, minus 2, plus 3, minus 4, etc. up to the last term, which is plus minus 1 to the n minus 1 times n, and that's equal to this sum. Right, first of all, we prove true for a particular value, so we'll do n is equal to 1. So the left-hand side is 1, and the right-hand side, if we substitute 1 everywhere there's an n, so there's a 1 there, and a 1 there, and a 1 there. So that will give me 1, minus 1 squared is plus 1. So it's 1 plus 1, and this will just be 1 minus 1 to the 1 times 1, which is minus 1 times minus 2, which is plus 2 over 4. That will give me 4 over 4, which is 1. Therefore, the result is true for n is equal to 1. Right, now here the fun starts. We're going to assume true for n is equal to k, i.e. 1 minus 2 plus 3 minus up until minus 1 to the k minus 1 times k is equal to 1 times minus 1 to the k plus 1 minus 2 to the minus 1 to the k times k over 4. Right, then we're going to prove true for n is equal to k plus 1. So we write this out and we add in the next term. So we get minus 1 to the k minus 1 plus 1, that gives me minus 1 to the k times k, which is now k plus 1. It's going to be equal to this, plus my extra term. And now what we need to do is work with this until we get the k plus 1th term of this. Okay, it's a little bit tricky this, so obviously common denominator of 4, which means you'd have to multiply all these terms here by 4. Right, I'm going to take out a minus, of these three terms here, I'm going to take out minus 1 of the k, which means here there will be another minus 1. Here there'll just be a minus 2k. Here there would be a plus 4k plus 4 if you multiply out that bracket. Again, it's all over 4. Right, next I'm going to do minus 1. This becomes plus 2k plus 2 plus 2. I'm going to separate the 2's up, okay, because if I factorize out here, I get the k plus 1, which is what I'm going to need for here. Right, so writing that term out again. And now it's a good idea, maybe, to write out what you expect to happen at the end. So what we expect to get at the end is 1 plus minus 1 to the k plus 2 times minus 2 times the minus 1 of k plus 1 over 4. This could be k as well, not k plus 2. It's exactly the same idea, because this just changes the sign. And this could be k minus 1. It'll be the same thing. Okay. Right, so working with this is what we're trying to actually prove or to achieve. Okay, so we've got 1, minus 1 to the k, minus 1, and obviously you're going to take out, so that gets minus 1 plus 2 gives 1, and then you're going to take out a common factor of 2, so we've got a k plus 1 term there. So we've got a 2 over 4. What we notice is that there's something wrong with the signs a little bit in there. So we're going to get 1 plus minus 1 to times minus 1. If I take a minus sign out of here, I get minus 1 minus 2k, k plus 1 over 4. So we get 1 plus minus 1 now to the k plus 1 if you combine these two here. And then we've got minus 1 times minus 2 to the k plus 1 over 4. Now, in fact, we've actually done it, because if we multiply that in here, we're going to get the minus 1 to the k plus 2. And here we're just going to get minus 2 times minus 1 to the k plus 1 times k plus 1 over 4. So it's quite a tricky process to get to the end result. So we can now say the result is true for n is equal to k plus 1, and then we need to write down our final statement. The result is true for n is equal to 1, and if it's true for n is equal to k, it is also true for n is equal to k plus 1. Therefore, the result is true for all n belonging to positive integers by the principle of mathematical induction. So what we are saying, if it's true for n is equal to 1, which is k is 1 in this time, it will be true for the next value, which is n is equal to 2. If it's true for n is equal to 2, it will be true for the next value, which is n is equal to 3, and so on for all the positive integers. Okay, so this has been a video to show you how to prove by induction the sum of a series with a much more difficult example. I hope you've understood, and I thank you very much for watching.